Hello everybody, welcome into another lesson. So today we are going to do some word problems, some real basic ones. So let's get started here. We have Luke has $5 more than Sam. Together they have $73. How much money does each person have? First thing, like yesterday's lesson, we were translating sentences into equations. You want to start out with some let statements. You want to define your variables. So we'll let the amount of money Luke has, let L equal Luke's money. We'll call that Luke's money. We'll let L equal Luke's money. And then we can let S equal Sam's money. So now we've defined some variables. Well, let's start with the second sentence. Together they have $73, so Luke's money plus Sam's money would equal $73. So together they have $73. Well, it says Luke has $5 more than Sam. So what that tells you is, since Luke has $5 more than Sam, Luke has equals Sam's plus 5. Because he's got $5 more than Sam. Luke has, which means equals, has also means equals in this setting, $5 more than Sam's. So it's going to be Sam's amount plus 5. Well, we've established that Luke plus Sam's money is totaled $73, but Luke has $5 more than Sam. We can take that S plus 5, substitute that in for the L. So what you're going to have is S plus 5 plus S is equal to 73. Simplify the left side, S plus S, that's 2S. You'll have 2S plus 5 is equal to 73. Now we just want to get 2S by itself. So you subtract 5 from 2S plus 5, you'll just get 2S, but what you do to one side, you got to do to the other. 73 minus 5 is 68. Well, we have 2S, we want to just find S, so you got to divide both sides by 2. Divide 2S by 2, you just get S. Divide 68 by 2, you get 34. So S is for Sam, so Sam has $34. Sam's got $34. Then we know Luke's is equal to Sam's, which is $34 plus 5. He's got $5 more than Sam. Well, 34 plus 5 is 39, so Luke would have $39. So we start out with what we're given here. Luke has $5 more than Sam. Together they have $73. How much money does each person have? We let L equal Luke's money. Let S equal Sam's money. We know together Luke and Sam, they have $73 because the second sentence tells you as much. So after you do your let statement, sometimes it's helpful to set up a general equation for the total amount. And then it tells you Luke has $5 more than Sam, so Luke's money is $5 more than Sam. We could take that $5 more than Sam, substitute that in place of Luke's, so you get S plus 5 plus S. Then you just simply do the algebra from there. You come up with Sam is $34, Luke is $39. And I guarantee you if you add 34 plus 39, you would get $73. And I do have more examples here. Yep, I definitely got more. Alright. What do we got for the next one? Let's see. There are 12 people on a jury. There are 4 more men than women. How many men are there? Alright, so we got 12 people on a jury. There are 4 more men than women. How many men are there? Well, again, let's start out with a let statement. We'll let M equal the number of men. We'll let W equal the number of women. Alright, so let M equal the number of men, let W equal the number of women. We know together the men plus the women equal 12 people. The men plus the women equal a total of 12 people. We got that much. So now it tells you there are 4 more men than women. So the number of men is equal to the number of women plus 4, because there are 4 more men than women. So it's the number of women plus 4. So now what we can do is we can use the fact that men is equal to the number of women plus 4. We can substitute that in for men. So what we're going to do is we're going to put in W plus 4 for where M is. Then we'll have plus W. That'll be equal to 12. Okay. Simplify the left side. W plus 4 plus W. That's 2W plus 4. That's going to be equal to 12. Well, we have 2W plus 4. We just want to get 2W, so we got to subtract 4. Subtract 4 from the left side, you'll just get 2W. But what you do to one side, you got to do to the other. 12 minus 4 is 8. Okay, so we have 2W. We just want to get W. Divide both sides by 2. Left side, you'll just get W. The right side, 8 divided by 2 is 4. So we have 4 women. But they only want to know about the men. Sometimes it helps to write the other answer on the side, but they're only asking about the number of men. The number of men is equal to the number of women plus 4. Well, there are 4 women plus 4, so the number of men equals 8. So there are 8 men. So the total you would get is 8 men. And I guarantee if you put in the 8 men plus the 4 women, you would actually get 12 people. So, again, this one was about there are 12 people on a jury, there are 4 more men than women, how many men are there? So I let M equal the number of men, let W equal the number of women, kind of defining good letters for our unknowns, for our variables. I put the fact that the number of men plus the number of women together equals 12. Now it said that there are 4 more men than women, so the number of men equals the number of women plus 4. I could substitute the number of women plus 4 for wherever I see the M. I did just that, did the algebra, got 4 women. Well, the number of men is equal to 4 women plus 4, and so the number of men was 8. And I got some more examples here. Alright, what do we got for the next one? Let's see, we got Lee bicycled 3 kilometers farther than Wayne. The sum of the distances they bicycled was 25 kilometers. How far did each go? Alright, so we got this problem here. Lee bicycled 3 kilometers farther than Wayne. Never knew anybody that has the name of Wayne, but hey, if there is anybody watching named Wayne, no disrespect, I've just never heard of it, so forgive me for my ignorance, but I digress. Lee bicycled 3 kilometers farther than Wayne. The sum of the distances they bicycled was 25 kilometers. How far did each go? Again, start out by setting up your let statements. So, define your variables. We'll let L equal Lee's distance. L will equal Lee's distance. We'll let W equal Wayne's distance. Alright, so we've defined our variables here for our unknowns. We'll let L equal Lee's distance. We'll let W equal Wayne's distance. So we know together, the sum of the distances they bicycle was 25 kilometers. So that means together, these two bicycled 25 kilometers. So we'll use the L plus W equals 25 to signify that together they bicycled 25 kilometers. So it says Lee bicycled 3 kilometers farther than Wayne. So Lee's distance was 3 kilometers farther than Wayne. So that's going to be Wayne's distance plus 3. Okay? Now, what we can do is we can substitute that W plus 3 in for where we see the L. So we'll do just that right now. We'll put in W plus 3 plus W equals 25. Okay, well, we'll simplify the left side. W plus 3 plus W, that would be 2W plus 3. We'll set that equal to 25. Now, we have 2W plus 3. We want to just have 2W. Well, we need to subtract 3 from the left side. If we do that, we'll just get 2W. But what you do to the left, you got to do to the right. 25 minus 3, well, that's 22. Now we have 2W, we want to just get W, we got to divide both sides by 2. So we do that, we'll just get W on the left, 22 divided by 2 is 11. So Wayne, since he's the W, went 11 kilometers. Wayne went 11 kilometers. Now we need to find Lee's distance. Lee is equal to Wayne's distance of 11 plus 3. 11 plus 3 is 14. So Lee went 14 kilometers. And if you add the two distances together, 11 kilometers plus 14 kilometers, in fact, equals 25 kilometers. So Lee bicycled 3 kilometers farther than Wayne. The sum of the distances they bicycled was 25 kilometers. How far did each go? So we let L equal Lee's distance. We let W equal Wayne's distance. So what we did is we used the fact that their two distances together, according to the second sentence, the sum of the distances they bicycle was 25 kilometers. So the two distances together is equal to 25 kilometers, L plus W. And it also states in the first sentence, Lee bicycled 3 kilometers farther than Wayne. So Lee's distance is Wayne's distance plus 3. I was able to substitute the W plus 3 in for where the L goes. You do that, you just do the algebra. You get Wayne has 11 kilometers that he bicycled, and then Lee went 14 kilometers. And let's see here, how many more? I got 3 more examples. We've got 3 more examples to get through, then we're done with the lesson. So these problems we're doing actually aren't that bad. Not bad at all. These are pretty simple word problems. Alright, let's see. We got Lisa walked 8 kilometers more than Tim. Lisa walked twice as far as Tim. How far did each walk? Alright, so we got Lisa walked 8 kilometers more than Tim. Lisa walked twice as far as Tim. How far did each walk? So this is a little bit different because it doesn't give you the total distance. Nonetheless, the process will be the same. For the beginning at least. We're going to use some let statements. We'll let L equal Lisa's distance. Then we'll let T, so I'll let T equal Tim's distance. Okay, so I've set L to be Lisa's distance, and I've set T to be Tim's distance. So we've used our foundational let statements to define our variables. Next thing we need to do is take these two sentences at the top into consideration. Lisa walked 8 more kilometers than Tim. So this tells you that Lisa's distance is equal to Tim's plus 8. And then it also states Lisa walked twice as far as Tim. So that means Lisa's distance is going to be equal to twice Tim's distance. Okay. So Lisa walked 8 more kilometers than Tim. So Lisa's is equal to Tim's plus 8 since she walked 8 more kilometers than Tim. It also states Lisa walked twice as far as Tim. So Lisa equals twice Tim, 2T. Well, if L equals T plus 8, we know L equals 2t. We could substitute the 2t in for the L. We could set 2t equal to t plus 8. And then all of a sudden, you got an equation with variables on both sides. We have 2t equals t plus 8. Well, it's probably safe to say we'd like to get the variable on the on the left-hand side, right? We have t plus 8 on the right side. We want to get rid of the variable out of the right side, so we subtract t from that. If we do that, we'll just get 8 by itself. Okay? But if what we do to the right, we got to do to the left. 2t minus t, that is t. Well, t is Tim's distance, so Tim went 8 kilometers. We got Tim's distance. He went 8 kilometers. Now, we got two statements for Lisa. We can use the fact that Lisa is Tim's distance of 8 plus 8. That would equal 16. We can also use the fact that Lisa's distance is twice Tim's, which would be 2 times 8. That would also be 16. Either way, we get that Lisa went 16 kilometers. Because 16 kilometers is 8 more than 8 kilometers, and it's also twice 8 kilometers. So, Tim went 8 kilometers, Lisa went 16 kilometers. So again, just start out by reading the equation, pick variables that make sense. I figure L would make sense for Lisa's distance. T would make sense for Tim's distance. And then we use the fact that Lisa's distance is 8 more kilometers than Tim's, and also Lisa's distance is twice Tim's distance. We can take twice Tim's distance, since that equals Lisa's, set that equal to Tim's distance plus 8. Do the algebra, you get Tim's distance is 8 kilometers, Lisa's is 16 kilometers. And if you put Tim's distance into either of these two equations, you get Lisa having 16 kilometers, so it checks out. On a side note, I want to say something real quick before we go on to the next problem. Because I forgot to mention one other variable yesterday in variables to be careful with. We covered S, T, and Z about being careful with those. Be careful with L. You can use the cursive L, that's fine, but you don't want to use the L that looks like a 1, because it looks like a 1. I would use the cursive L if you're going to use the letter L. So, forgive me for forgetting to mention that. It slipped my mind yesterday, but I just thought while we're here I should cover that. Alright, we got 2 more problems and then we're done for the day. Let's see. Shelley made 5 more sales calls than Clark. So Shelley made 5 more sales calls than Clark. Shelley and Clark made a total of 33 sales calls. How many sales calls did each make? Alright, so we got this problem here where Shelley made 5 more sales calls than Clark. Shelley and Clark made a total of 33 sales calls. How many sales calls did each make? Well, again, let's pick some variables that make sense. I'm going to vote that we let S equal Shelley's calls. So I'm picking the variable S to represent Shelley's calls. I'll let C equal Clark's calls. So I picked S to represent Shelley's calls. I picked C to represent Clark's calls. Now that we've established our variables for the unknown, the second sentence tells us that Shelley and Clark made a total of 33 sales calls. So together, if you take Shelley's calls S plus Clark's calls C, they made a total of 33 calls. Add them together, they made a total of 33 calls. Now this tells you that Shelley's calls is equal to 5 more calls than Clark's, or Clark's plus 5. So Shelley made 5 more calls than Clark. So Shelley is equal to Clark's plus 5. What we can do now is substitute C plus 5 in for where S is in the original equation. So let's go ahead and do just that. Clark's plus 5 plus Clark's equals 33. Simplify the left side, C plus 5 plus C, we get 2C plus 5. That's equal to 33. Okay, well, we have 2C plus 5. We just want to get 2C. We got to subtract 5. We do that on the left side, you'll just get 2C is equal to, now we got to do it to the right side, 33 minus 5, that's 28. Well, we have 2C, we just want to get 1C. Just get C, we got to divide both sides by 2. You divide the left side by 2, you just get C. Divide 28 by 2 on the right, you'll get 14. So C equals 14, which means that's the number of Clark's calls. So Clark made 14 calls. So Clark went ahead and made 14 sales calls. Now it says that Shelley made 5 more calls than Clark, so Shelley's is equal to Clark's number of 14 plus 5. So that means Shelley made 19 calls. So Clark made 14 calls, Shelley made 19 calls, and if you add 14 and 19 together, you'll get 33 calls. That's exactly what you would get. So, once again, I read the problem, set up my variables that made sense. S would equal Shelley's calls, C would equal Clark's calls. The second sentence tells us together that Shelley and Clark made a total of 33 calls. So I put S plus C equals 33. And now the first sentence tells us that Shelley made 5 more calls than Clark. So Shelley's is equal to Clark's plus 5. S equals C plus 5. Then I was able to substitute C plus 5 in for S. I did the algebra. I got Clark having 14 calls, Shelley having 19 calls. So that's how we arrived at that conclusion. And I got one more problem. See, these problems aren't too bad, actually. Word problems can seem scary, but one of the biggest things you got to do is a let statement. You got to start out defining variables that make sense right away, and then really read what is the problem saying. Don't overthink it. And in the future, we're going to get into types of problems where they throw information at you that you really don't need for the problem. It's important to be able to decipher what you need and don't need. But that's for another time. Alright, last one. Let's see. Amanda spent $2 more than Barry on school supplies. Together, they spent $34. How much did each spend? Okay, so Amanda spent $2 more than Barry on school supplies. Together they spent $34. How much did each spend? So let's start out, let's pick some variables that make sense to define how much each spent. We will let A equal Amanda. Then it only makes sense to let B equal Barry. We'll let B equal Barry. So that's the biggest part to start with, is using your let statements to define variables for each person. You know, for the amount they spent, or the amount of distance they went, or amount of calls they made, what have you. Second sentence tells us that together they spent $34. So Amanda A plus Barry B, together they spent $34. So A plus B equals 34. That's what you would get to start with. Go back to the first sentence. Amanda spent $2 more than Barry. So the amount Amanda spent is going to be equal to Barry's amount plus 2. So she spent $2 more than Barry, so it equals Barry's plus 2. A equals B plus 2. Since A equals B plus 2, we could substitute the B plus 2 in for where we see A. So we'll have B plus 2 plus B equals 34. Okay? Left side, B plus 2 plus B, when we simplify that, it turns into 2B plus 2 equals 34. Well, we got 2b plus 2. We just want to get 2b. We got to subtract 2. We do that to the left side, you'll in fact get 2b. But what you do to the left, you got to do to the right. 34 minus 2, that's 32. Well, we have 2b equals 32. We just want to get b. You got to divide by 2. Divide the left side by 2, you'll just get b. Divide the right side by 2, 32, you'll get 16. I need to clean this board. Man, I'm really slacking. I need to clean this board. Okay. So we got B equals 16, which means Barry spent $16. So we solve for Barry's. He spent $16. Now it tells us Amanda spent $2 more than Barry. So that's going to be Barry's amount of 16 plus 2, which means Amanda, 16 plus 2 is 18. So Amanda spent $18. And if you take their amounts of $18 plus 16, you'll in fact get $34. So, whenever you're given a word problem, start out, read the problem, see what you need. Always use let statements to define what your variables are, who, pick variables that make sense, like A for Amanda, B for Barry. Those make sense. And sometimes the first sentence isn't always what you start with. I mean, you can if you want, but it can make your life harder. Always look for together statements. If they do have a together, like they spent or they wrote or they made, start there. Like together, Amanda and Barry, they spent $34. That's an example. Now, in the first sentence, it tells us Amanda spent $2 more than Barry, so Amanda's amount would equal Barry's plus 2. You can do some substitution, take that Barry plus 2, put that in place of Amanda's, and then you do some algebra. You come up with Barry equals $16. Substitute Barry's amount into the substitution equation. You get Amanda's equals 18. So that's it for this lesson. Next lesson, we're going to do some absolute value equations. I don't believe I taught that in pre-algebra, so this will be a little bit of new territory here. We'll teach you how to do absolute value equations. So I hope everyone has a good night. Take care.